Today we're going to start our discussion of trigonometry with some right triangle problems. We're going to do 3 sections of trigonometry, 3 big units, and the first one's going to be all about triangles. You know a little bit of trigonometry already. You've probably done some right triangle problems in Algebra 1 and definitely in geometry, and you probably learned about 3 ratios. And they are sine, cosine, and tangent. I would guess that everybody has heard those words. And you probably learned that sine equals opposite over hypotenuse, and that cosine equals adjacent over hypotenuse, and that tangent equals opposite over adjacent, and that just lets you find the sine of an angle by dividing the side length opposite it by the hypotenuse. I'm not sure. I think a lot of people learn these 3 words, sine, cosine, and tangent, and don't really understand them. They're ratios, meaning if the angle is a certain width, it's a certain amount of degrees in a right triangle, then the 2 sides in question, opposite, hypotenuse, etc., those, whichever 2 sides, they will always be the same regardless of the size of the triangle. So if I take this same triangle and double it, make it 10 and 26, by the way, we're going to need to know this third side in just a minute. That third side is 12 using the Pythagorean Theorem, or if you remember that 5, 12, 13 is a Pythagorean Triple, meaning it's just a set of 3 numbers such that 5 squared plus 12 squared equals 13 squared. 25 and 144 equals 169. But if you didn't remember that it was 12, you would just solve that equation. But anyway, back to my original point. If I doubled the size of my side lengths, and I made this theta still, it's the Greek letter theta, which is usually used for angle, the sine of theta is the same. It's just the ratio. Because opposite over hypotenuse, which is 12 over 13, is equal to 24 over 26. Okay, so hopefully you'll get a little bit deeper knowledge and understanding of what trigonometry really is, but you probably have a little bit of the basics right now. So that is kind of a side note about just what trig is. So let's just get back to the problems that you're going to need to know how to do today. So remember, if sine, cosine, and tangent, sometimes they are remembered with Sohcahtoa, which just means that sine equals opposite over hypotenuse, S-O-H, so, C-A-H, toa. It's a very common one. I learned it when I was in school. Your kids will probably learn it when they're in school. If you don't like it, you don't have to use it, but that's how you remember that if you have an angle theta, the sine of that angle is the opposite. So I'm going to move across it, and then it's over top of the hypotenuse, which is 13. I'm not going to spend a lot of time talking about what opposite and hypotenuse and adjacent mean, because again, you've probably done this in 2 other math classes, and we have other things to talk about. Okay, now, Sohcahtoa, those are probably the 3 trig functions you've learned. You may or may not have encountered 3 other trig functions. Definitely, if you have not, write this down, but everybody write this down. Sine kind of has a little partner, and it is called cosecant. Cosecant of an angle is the inverse of sine. Inverse as in, I should say reciprocal, I guess. It is the sine flipped over. It's 1 over the sine. So cosecant, you have a couple options. You can find the sine and then flip it over, or you could do hypotenuse over opposite. All right, that's called cosecant. Cosine's partner is secant. Secant of theta is 1 over cosine theta, And since cosine is adjacent over hypotenuse, this would be hypotenuse over adjacent. And it seems like cosine should be paired up with cosecant because they both start with co, but that's not the case. Sine goes with cosecant, cosine goes with secant. Cotangent is 1 over tangent. And it is, since tangent is opposite over adjacent, it's adjacent over opposite. So by learning these three, which is really just flip-flopping the three you already have, you're able to have 6 total trig functions. So this next question says, what is the secant of theta? Well, so the thought process would be secant is the reverse of cosine, so it's the hypotenuse over the adjacent. The hypotenuse right here is 6. The adjacent is 5, so secant theta is 6 over 5. All right, cosine theta would be 5 over 6. Therefore, secant theta is 6 over 5. I didn't have to find the missing side because it asked me for the secant. If I needed to have opposite, then I would use the Pythagorean theorem to find the missing side. All right, so definitely this, I'm guessing, is new for a lot of you. Maybe not for some, but those are the 3 other trig functions. All right, so here's a little different spin on these questions. Find sine theta if cosine theta is 1/3. So what they're asking us to do here is come up with a right triangle that has sides such that wherever your angle is, the cosine of that angle is 1 over 3. And remember that cosine is adjacent over hypotenuse. So there's 1 and there's 3. So what you're going to want to do is draw a little generic right triangle with an adjacent to the angle 1 and a hypotenuse of 3. And it doesn't really matter if it's to scale, right? My 1 should be a lot smaller in this case, but I needed to make it adjacent to the angle, not opposite. Now, based on this triangle and this angle, what's the sine? Well, sine would be opposite over hypotenuse, so I need to know what the opposite is. Okay, well, if I want the opposite, basically I need to do 3 squared minus 1 squared, which is 9 minus 1, which is 8. So, square root of 8 is that side length, okay? Should put those in there maybe. All right, this Pythagorean theorem, 1 squared plus x squared equals 3 squared would be the equation. I just kind of sped that up a little bit. So now what's the sine? Sine of theta is opposite over hypotenuse, which is the square root of 8 over 3. Okay? So I wasn't looking at a triangle. I wasn't given an angle. I was just given another ratio. If you're given a ratio, you're given 2 side lengths. And by the way, this could have been 2, 6, and 2 times the square root of 8, and nothing is changing. All right? So that's a style of question. Here's another style of question. You probably did this in your classes. This is kind of using trig backwards. This is saying, I'm going to give you the ratio, you give me the angle. Well, if this is the angle in question, this question mark, that's what they're looking for. If you want to know the angle, go ahead and set up the ratio that you would use. I have the opposite and the adjacent. I have nothing, no info on the hypotenuse. I could find the hypotenuse if I needed to, the Pythagorean theorem, but I'm given the 24 and the 50, so let's use those. So what trig ratio uses opposite and adjacent? Now that you know your 3 new ones, you could use cotangent or tangent, but usually in this case you'll just use sine, cosine, and tangent since those are the main 3. Tangent of question mark is equal to 24 over 50. Okay, so how do you figure out what that is? Well, you're going to have to go to the calculator. Make sure that your calculator's mode is in degrees. For a graphing calculator, you'll hit the mode, and then you should have a radian or degree option. Most calculators will have that somewhere. Now, see the tangent button. Right above tangent is tangent to the negative 1. All right, tangent to the negative 1 does not mean 1 over tangent. Right, x to the 1 to the negative 1 is 1 over x. But that's because that's a multiplicative inverse. Tangent to the negative 1 means inverse tangent. And if you want to know what the angle is, you need to do inverse tangent. All right, so to answer this question, we go second tangent to get tan to the negative 1 of 24/50ths. And if our calculator is in degrees, we get our answer. And it's 25.6 degrees. If your calculator were in radians, you'd get something totally weird, and we'll learn about that soon. Okay, but this is inverse trig. It is finding the angle given the two side lengths. All right, lastly, solve the triangle. Solving a triangle means finding everything that's missing. There are 6 parts to every triangle, 3 angles and 3 sides. So we're going to take what's given, and you have to be given 3 parts, by the way. In this case, we're given an angle, a side length, and a right angle. So we're given 2 angles. Let's start with the easy one. Let's start with the missing angle. So there's a very important rule in geometry that you learned that said all triangles must add up to 180 degrees if you add up their 3 angles. So I've got 90 taken care of, got 65 taken care of, so I need the rest. And so minus the 90, I need the 65 and angle A to be another 90. So I believe that's going to be 25, 65 and 25. So there's one answer. The measure of angle A equals 25 degrees. We're going to go ahead and use proper notation, might as well. M angle A, measure of angle A equals 25 degrees. Be in the habit of using the proper notation. And now we're going to have some options here, but I would recommend using the 25 because that was given. If you make a mistake, use the 65 because it was given. If I made a mistake on the 25 and then I use the 25 to find further information, then all of that's going to be wrong too. So my suggestion is always going to be use the givens to find all of the parts. All right, so let's find let's find the hypotenuse, BA. If I have the 65, 23.6 is opposite that. And BA, what I'm looking for is the hypotenuse. Okay, so sine is opposite over hypotenuse. 65 and 23.6 were both givens. Technically, the 2 steps that are going to happen to solve this equation, by the way, I don't mean BA as 2 different things. That's just, I could call it X or whatever. I just called it BA to represent that side length. The 2 steps that are going to happen, I'm going to multiply both sides by BA, and I'm going to divide both sides by sine 65 degrees. But really what happens if you want to simplify that process, anytime you have one quantity equal to a fraction, you can interchange these 2. So BA will equal 23.6 over sine 65 degrees. All right, 23.6 divided by sine 65 is 26.0. Okay, and always make sure your answer is reasonable. You can find a lot of wrong answers if you will just eliminate unreasonable answers. I got a hypotenuse of 26, my side length was 23.6, so this is reasonable. So there's 2 of the 3 parts. Now, my options, I've got a lot of options for finding BC. I don't like using that 2-letter for my unknown, so I'm just going to call BCX. All right, so what are my options? There's several things I could do. I could use the 25 and do like tangent. I could use the BA that I just found. I could use the Pythagorean Theorem. Again, I'm going to use what's given because I know that's safe. Ideally, what I would do is check it a couple ways and make sure that I confirm my previous answers. But to keep with my rule of using what's given, I want to use the 65 and the 23.6. 23.6 is opposite, x is adjacent, which means tangent 65 degrees equals 23.6 over x. Exchange the x and the tan 65. Divide and see what you get. So my answer is going to be 23.6 divided by tangent 65 degrees, and that's 11.0. And it makes sense. That's the shortest side of the triangle. So now that triangle is solved. All right, so it's time to wrap this one up, but we're doing right triangle trig. Hopefully you learned a little something new in here. A lot of old, little new, Sohcahtoa, secant, cosecant, cotangent. Fantastic. Young out.